8th lecture. So, we will continue with the last 7th lecture, what we have been discussing about the Euler's theorem. So, we were working out how to get A tilde and phi from the C matrix, which is the rotation matrix. So, continuing with that. So, what we require to discuss that what happens when phi equal to plus minus pi plus minus 3 pi and so on. Okay. So, for this case, we know that once phi equal to plus minus pi. So, the corresponding value of delta is, this implies delta equal to minus 1, this already we have observed, and therefore, the C can be written as cos plus minus pi. So, here we will replace this as, say if we are using pi. So, cos pi plus 1 and then multiplied by I 1 minus cos pi, then multiplied by A tilde transpose minus sin pi times A tilde. So, what we observe from this place that this term vanishes. Okay. This is pi. So, this term is 0 and we are left only with this term. So, this is minus I plus 1 cos pi equal to minus 1. So, this is plus 1 times A tilde transpose. So, minus I plus 2 times A tilde transpose, and then of course, we need to expand it. So, if we expand it, so this will look something like this: A 1 A square, this particular term A 1 A 2, A 1 A 3, A 2 A 1, A 2 A square, A 2 A 3, 3 A 2 and A 3 A square, and minus I, which is 1 1 1 0 0. Okay. Therefore, this C can be written as 2 A 1 A square minus 1, and of course, this will be 2 A 1 A 2, 2 A 1 A 3. Similarly, 2 A 2 A 1, 2 A 2 A square minus 1, 2 A 2 A 3, and here 2 A 3 A 1, 2 A 3 A 2, and on this side we have 2 A 3 A square minus 1. Okay. Now, of course, you know that C is C 1 1, C 1 2, C 1 3, C 2 1. So, compare these terms. Okay. So, if we compare these terms, I am writing here in this portion. So, we can see that C 1 1 this equal to 2 A 1 A square minus 1, and this implies A 1 A square equal to C 1 1 plus 1 divided by 2. Okay. And this implies A 1 equal to plus minus 1 plus C 1 1 divided by 2 under root. Now, the problem here is that plus and minus sign is appearing. So, which sign to choose? Okay. Similarly, if we look for the other one, so A 2 will be plus minus 1 plus C 2 2 divided by 2 under root, and A 3 will be plus minus 1 plus C 3 3 divided by 2 under root. So, all of them having plus minus sign. So, this is the ambiguity. So, with this value we get this ambiguous case which we need to resolve, but this so happens that this can be resolved by using the off diagonal terms. So, if we look into the off diagonal terms, we go on the next page. So, for the off diagonal terms, we can have 2 A 1 1 A 1 A 2 minus 0, 0 we have already removed. So, we will remove here also. this gets reduced to C 12, okay. And this implies A 1 A 2 equal to C 12 divided by 2. Similarly, we will have A 1 A 3 from the other terms. So, here A 2 A 3 equal to C 23 divided by 2, and this gives us C 13 divided by 2. So, now A 1 and A 2, this C is fixed, is not it, because this is given, C matrix is given. So, this right hand side is fixed, and left hand side in the previously we are getting A 1 equal to plus minus 1 plus C 11 divided by 2 under root. So, here this ambiguity is there, and let us say the A 2 also the same way 1 plus C 22 divided by 2 under root with plus minus sign. Okay. However, if you look into this multiplication, whatever the sign of this C 12, this value, suppose this is 1 or minus 5 whatever. So, accordingly A 1 and A 2 must be chosen. So, using this we will be able to resolve this ambiguity, at least here in this case, and therefore, it is not as problematic as the case with phi equal to 0, 2 pi, 4 pi or minus 2 pi, minus 4 pi, etcetera. So, this case is ambiguous, but this ambiguity can be resolved, and therefore, A 1, A 2, A 3 and the phi can be decided how much it is. Now, some other issue also we have to look into the issue with the involved with the phi angle. So, there can be ambiguity with the phi angle itself, because if we look here, say if this is my A vector, okay, and from here I give rotation from this place to this place by angle this phi. Okay. So, the same thing can also be achieved by, this is your initial position, okay, and here we are currently. So, if we go doing like this, first we have rotated here from this side to this side, this is rotation like this, and if we rotate this way, okay, so along the minus A tilde axis. Okay. So, if we rotate along this axis by say phi prime from here to here by phi prime equal to 2 pi minus phi. So, we get the same vector. So, here the problem arises, because the same position can be achieved either by through rotation pi here this way, or either through rotation given in the opposite way, which is another rotation is given this way, but about the minus A tilde axis, and both are going to the same position. So, this will create problem. So, to restrict this, to resolve this problem, it can be done that this is restricted to phi is restricted to 0 to phi is restricted to 0 to pi. So, so whenever this problem arises, we need to resolve it carefully to work out this particular solution. So, and if we do this, then our whole ambiguity will be removed, and we will be able to do the problem correctly. And this part, this is also obvious from 1 by 2 sin phi times C transpose minus C. So, what we can see that if phi we give, so we get certain A cross. If we give 2 pi minus phi here in this place, so we will get a minus sign. So, that rotation is just the opposite one, okay, and both will lead to the same position. That is, if this is say here your rho vector, so here this will be the rho prime vector. So, either you go this way or either you go this way, both are possible, and to resolve this ambiguity, therefore, we are keeping this phi value whenever possible, of course, whenever possible, to restrict it to 0 to pi. Otherwise, on the case to case basis, we need to discuss resolve this particular problem. And as an example, lastly we consider this matrix consider that A tilde is given to be 1 0 0. So, that means it is just like you have the x, y and z axis. So, this is indicating a vector along this direction. Okay. So, A is a unit vector which is lying along this direction. Now, if we insert into this, so this becomes cos phi I plus 1 0 0 A cross. So, A cross the diagonal elements will be 0 and here minus A 3 which is 0, A 2 which is also 0 and A 1 with minus sign here. So, this is minus 1 and here we are getting for that reason 1, all other terms are 0. And if we add all of them, so this is your cos phi 0 0 0 cos phi and this will give you only one term here 1 minus cos phi which will and rest other terms will be 0. And in the same way here 0 0 minus sin phi and 0 sin phi 0. So, if you add all of them, so this will yield cos phi plus 1 minus cos phi and then this term is 0. So, that term is removed, rest others they are 0 0. So, this is 0 0. Similarly, here 0 0 0. So, this term remains 0. The second term cos phi 0, here it is 0. So, second term is cos phi and third term here 0 0 and this is minus sin phi and this minus minus that gets plus. So, this is sin phi and again this term will be 0 0, this is 0 0 and this is sin phi. So, sin phi comes here and lastly this cos phi 0 and 0. So, this is cos phi. So, here this comes with minus sign. So, we are putting minus sign this term it cancels out and that leaves it with 1 0 0 0 cos phi sin phi 0 minus sin phi and cos phi. So, we can see that this C matrix if A is the vector given. So, the x axis. So, this gets reduced to this format and we are aware from our earlier discussion this is nothing but rotation about the x axis by angle phi. So, this is what this theorem states. So, this is the rotation about the vector A by angle phi and exactly what we are getting here in this place. Now, the question arises what happens if two rotation matrices given by C equal to cos phi I plus 1 minus cos phi sin phi A tilde transpose cross sin phi A tilde cross. So, these are multiplied means we have a composite rotation. So, if this rotation indicates rotation about the A tilde axis by phi, okay. And we have another rotation. So, let us say that C 1 is one rotation which is being defined as cos phi 1 A 1 tilde transpose minus sin phi 1 A 1 tilde cross here, and another rotation matrix is being defined as so, if we give this rotation first, okay. So, that is rotation about the A 1 eigen axis. So, this is rotation about A 1 tilde eigen axis. Next, we give rotation about the A 2 tilde for to the same body, okay, A 2 tilde eigen axis. So, obviously, this one is composed of 3 rotations in general. This also it is composed of 3 rotations. So, if we operate like this, so this is composing of 3 rotations, this is composing of 3 rotations. So, total it is a composite rotation, one rotation must total it is equivalent to a single rotation. So, from here also if we multiply them, so it should turn out that this is equivalent to a single rotation, which can be written in the format which we should be able to write in a format as say the cos phi 3 I plus 1 minus cos phi 3 A tilde 3 transpose minus sin phi 3 A tilde 3 cross. So, where A tilde 3 this is the now eigen axis for the composite rotation. And phi 3 this is the effective or the resultant rotation of this operating by C 1 and C 2 rotation matrix. This is the effective rotation about A 3 tilde. However, proving this it is a very strenuous and mathematics is very long. So, rather we will put this as the tutorial problem, and here I will give you the final result. So, obviously, if this is the case that I am representing this C by this the operation of these two matrices C 2 operating on the C 1, okay, then this also must satisfy all the properties of the rotation matrix. Okay. This needs to be proved. So, if we try to do that, so this we have written as, let us say the first rotation we are writing as C D E, which is the rotation from E frame to D frame. This is the rotation from E frame to D frame, and then from D frame to B frame. So, D is the intermediate frame. D to B frame means C B E we can write as C B D times C D E, and this must satisfy all the properties that we have proved earlier for this to be a rotation matrix. So, for the composite rotation this C B slash E, it can be proved that will set as the tutorial problem, this 3 times C1 C2, where C has the usual notation of cos. So, this is indicating cos phi 1, this is indicating cos phi 2, where phi 1 and phi 2 are the rotation about the a 1 vector and the a 2 vector respectively. Gamma, this is the angle between a 2 tilde and a 1 tilde. Similarly, this is indicating sin phi 1 and this is sin phi 2. Okay. And lastly, we have other two terms plus C 2 times 1 minus C 1, C 1 times 1 minus C 2. And this can be further simplified. So, if we try to simplify this, will look in this format: C 1 C 2 so this is trace C B slash E. Where a number of identities need to be used to prove this final form, and it is a very strenuous. So, we are avoiding this and we will take up this in the as a tutorial problem rather than doing it in as a lecture problem. Okay. So, from this place then you will get cos phi 3 as usual 1 by 2 this trace of C B slash E minus 1. Okay. It is possible to put this in a little more simplified format, and this can be done using some simple rules, but for the time being we are not going to ponder over all those things. So, if we try to work out this, where you remember that C 1 is cos phi 1, C 2 is cos phi 2 and so on, and here S 1 S 2 they are appearing as sin phi 1 and sin phi 2. So, it can be proved that cos phi 3 divided by 2 this equal to plus minus cos phi 2 divided by 2 minus sin phi 1 psi phi 1 divided by 2 . So, this can be reduced into this format. Here remember that this particular one. Okay. Using this, so insert this into this, and then finally, this can be written in this format. So, from this place it is easy to work out this phi 3 and 2. Now, this plus minus sign what is appearing here, this must be resolved. Okay. So, what we see that when phi 1 equal to 0 and phi 2 equal to 0. So, this part will get reduced to 0 and this part will get reduced to plus 1. Okay. Okay, and therefore, so the sign ambiguity whatever is existing here, this can be resolved . because if we are not giving any rotation, you can see that if we are not giving any rotation, phi 1 and phi 2 they are 0. Therefore, the composite rotation must be 0, there is no rotation. So, phi 3 must also be 0. So, on the left hand side this turns out to be plus 1. So, right hand side also must be plus 1, and therefore, this sign gets resolved here. So, we pick up the plus sign from that place. So, using this technique you will be able to resolve the sign problem. And in the same way, then you can define if delta as earlier written, delta not equal to 3 and minus 1. So, in that case you are defining this A 1 as 1 by 2 C 2 3 minus C 3 2 by sin phi and so on, 1 by 2 . So, whatever this case already we have discussed for a single C matrix. Once we multiply it, once the C 1 is multiplied with this C 2. So, for that case also the same thing is applicable. So, here in this case this is referring to the case where your C matrix, the final C matrix you are writing. So, those components will be written in this way, and A 1 is defined like this, and vice versa the same way you can do exactly. Okay, so, we will this process will be more it will be more consolidated once we look into the problem set, the tutorial set. So, once you try to work out interact do the mathematics. So, it will be much more, the concept will become much more stronger. For finding out, this is the equation we have been using. Okay. So, for this here C is nothing but C B slash E, which you have written as B slash D C D slash E. So, we need to find out this, and then need to take the transpose of this, put here in this place, put here in this place, and then work out with this to solve the problem. So, it is a very lengthy and very strenuous. Okay, so, this portion we are going to skip, and we are reserving it for our this particular tutorial problems. So, I will write the final result here. This can be written as 2 sin phi remember gamma is the angle between vector A 1 and A 2. Okay, so, this is what you get once you write it in this format on the right hand side. Okay. This is consequence of, here we need to remove this particular part. Okay. So, as a final result this is what we get A tilde, or if you write in vector notation. So, simply you write as A. So, this quantity will be given here in this format. Obviously, this is quite long still, but seeing the whole thing, the original, if you try to prove this, putting this C matrix from this place C transpose and then C, and then trying to work out, it stretches over a number of pages. But it so happens that this can also be little bit more simplified and put into a simpler format. So, this A 3 matrix or the A 3 vector or the A vector, which is the composite eigen axis rotation, okay, or composite eigen axis. So, this can be written as 1 by the previous equation what we have written, it can be reduced in this format. This is a little more simplified format, where cos phi 3 divided by 2, this is written as okay. So, once we know this, so we can observe something very interesting from this place, that this suggests that A 3 sin phi 3 by 2, this is of special importance, and similarly cos phi 3 by 2, this is of also special importance, and this we can generalize as A tilde sin A tilde 3 sin phi 3 divided by 2, this we can write in terms of epsilon 1, epsilon 2, epsilon 3 equal to epsilon tilde. Actually, here in this place where the quaternion notation starts, rather than telling that it is a quaternion, these are called the Euler parameters. Because the quaternions we use the notation q 1, q 2, q 3, q 4. So, this is for quaternion, and here it was developed by Hamilton, okay, and this especially deals with the 4 elements hyper complex number. So, till 12th we have done just like the x plus I y, this we have considered as a complex number, okay. But here what we see that this is 2 element complex number, okay. But this one is defined as the 4 element complex number, where this is the real part and these 3 happen to be the complex part. So, it so happens that whatever the equations developed using this, they can also be derived using this, but this is basically the complex notation, and this we are working with the matrix notation. So, rather than calling this as the quaternion, we call as the Euler parameters. However, if you are doing the mathematics, so equivalently you can say that we are working with the quaternions, but in a strict sense this is Euler parameter, and here this set is the it is called the Hamilton this quaternions, which was obviously developed by Hamilton. Okay, so we define epsilon tilde like this, and then we define eta as cos phi 3 divided by 2, which is appearing here in this place. So, this particular part and this part, this is of special significance, and what if we see that epsilon 1, epsilon 2, epsilon 3 and eta, these are the 4 parameters involved, but in a rotation we have only 3 rotation angles involved, which is psi, theta, phi. Okay, these are the only 3 Euler angles involved. These are the Euler angles. So, here one extra parameter we are getting, but it so happens that, as we will see later on, that epsilon 1 square plus epsilon 2 square, epsilon 3 square plus eta square, this turns out to be 1. Okay. And therefore, means one of them can be expressed in terms of the other 3. So, only 3 independent parameters are there, not 4, as here in the case this Euler angle representation, only 3 independent rotation can be given. Similarly, so corresponding to that the 3 parameters should appear here. However, here it is 4, but one is dependent on the other 3. Now, advantage of using this particular notation is that it is free from the trigonometric notation. So, to get rid of the trigonometric notations, we can use the Euler parameters or the quaternions, whatever way you say is equivalent, but not in the strict sense. So, our trigonometric process, it gets reduced to a very simplified algebraic process, and therefore, in many problems where the large angles are involved, rather than working in terms of psi, theta, phi, we rather work in terms of epsilon 1, epsilon 2, epsilon 3 and eta, which are the Euler parameters. So, we will continue with this in the next lecture, where we will wind up this quaternion, and whatever the mathematics we have not developed. So, this mathematics will go as part of the tutorial, where we will be able to work out those. If you face any problem at that time, so we will interact and then resolve all those problems. Thank you very much for listening.